All right, we're doing this. Today we are finding the solution between non-linear systems. So one of them might be linear, but they both aren't linear. See, the first picture is a circle and a line, where the circle and the line intersect twice, so we might have more than one answer. We could have just one answer with a circle and a line. It could look like this. Do you know what that's called when a line just touches a circle once, just like that? Tangent, yes. Totally related to the tangent we were doing in calculus. That's right. It could also have no solution. Here we've got a parabola in a circle. They could cross 3 times. They could cross no times. They could cross 1 time. They could cross 2 times. Could they cross 4? You have 4. Could. This one is a circle, and does anybody know the name of that other cross?
Cosine. Sine. Tangent.
It's called, it's actually right here. It's called a hyperbola. There is ellipses also. Does anybody know what ellipse is?
That's just not
No, it's like an oval. We could have to do with the moon. Eclipse. The 1 letter difference. An ellipse is like a circle that has a stretch horizontally or vertically, so it's like a oval, basically. We will learn how to graph all of those later in this book, just not yet. So you're not going to be graphing them. You're just going to be finding the solutions. I do want to write down the equation of a circle. You should have learned that in geometry. Don't look at me like that, because I would get your geometry stuff out. Because when I'm not being so nice. Oh, so we did learn about circles when we did complete the square. The kind of equation of circles. Right before air testing. Oh, I remember it clearly. Anyway, the equation of a circle has x squared plus y squared equals what's r? Radius squared. It also could be written as x minus h squared plus y minus k squared equals r squared, where hk is the center. Oh yeah. Where's the center for that first one? The origin at 0, 0. That's why there's not an H or a K. There is, you just don't see them.
So you use the HK formula for
You could use the HK formula if it is at origin. It would just be a 0 and a 0.
if it's not there, you have to use that.
There is a third circle formula, which is later in our notes. It would be the general formula. I'm not going to write it now, but yeah, it's not important. Yeah. We'll get to it. Parabolas, remember, just a quick review, parabolas, quadratic, y equals ax squared plus bx plus c, or you could have it in vertex form, a parenthesis x minus h squared plus k, and hk would be the, what's it called? It's kind of the same thing, but it's not. The vertex, the center of the circle is like in the middle of the circle. The vertex of the parabola is that middle point. related, but they're not. Okay, so I'm giving you this information for the future. You won't need to write the equation of a circle or parabola yet, but you will in the future. So that's there. What we're actually doing today is just finding the intersection algebraically and with our calculator. So we're going to use substitution. The first thing that I'm going to say is helpful to get you started. Remember, when you use substitution, you have to solve one of the equations for one of the variables. How do you choose which variable? You know?
Yeah, the one that has like a symbol with extra y term. I guess that's how I put it.
Yes.
U and minus 2.
Yes. Yes, except now when we have nonlinear, you have an x squared, and you have an x, and you have a y somewhere in here, okay? What you want to solve for is the one that is not like the others. So we have an x squared and we have an x. Those are kind of related to each other. So the y is kind of the oddball. You will want to solve for y. I don't care if it has a number in front of it. You want to solve for the one that doesn't have the squared with it. Otherwise, you're going to have a hard time. You will make it as efficient, as easy as possible. Solve for the one that doesn't fit. Yeah.
So we, like, if there's like a squared variable and a non-squared of that variable, solve for like
The other variable. Yeah. So we might have an equation that has like a y squared. I don't know. So this one I would want to solve for x. Okay? So we're going to solve for the one that is not like the other. And I'm going to choose the equation that looks easier to solve for y.
Second one.
Second one, yeah. So I will use that one. I'm going to solve that for y. That's going to give me y equals 2x plus 1. And we will plug that into the first equation for y. We use substitution. Now we just solve for the remaining variable. I'm going to get rid of my parenthesis by distributing that negative sign. And we're going to solve for x. But we have an x squared. So now we have to go back and like think about how you solve when you have an x squared. How do you solve when you have an x squared?
Factor.
Or, that's one answer, factor, or, what if you can't factor it?
Square root.
Quadratic formula. You could do square roots if you didn't have an x term. But since you have an x term and an x squared, square roots doesn't work. So your choices really are quadratic formula or factoring. There is a third thing called complete the square, but I never use it, so. Either way, you're going to have to make it equal 0. And then choose which method makes the most sense. Does factoring work?
Yes.
Okay, then I'm going to do it that way. If factoring didn't work, then I would do quadratic formula. We got.
X has 2 answers.
Mm-hmm. It's okay, we'll get there. I know, it's so exciting, isn't it? So after I factor it, how do I find my x values? Set each factor equal to 0. So for each factor.
Hold on. How did you get the negative 8? Is
I made the 7 over.
okay.
Did you not get a negative 1?
So you know how to factor for that? Just like what I did was just simplify x squared plus 2x minus 1 equals 7. You have to factor.
It has to say equal 0 first before you factor. Because then you have to set each factor equal to 0. So it has to say equal 0 first. Okay. All right, so now we have 2 x's, but we are trying to find the ordered pairs of where these two things cross. By the way, the first thing is a parabola because x is squared. The second is just a line. So we've got a parabola and a line. They cross twice. So we have two different answers. So we do what we did yesterday where we substitute back in one number at a time. Start with x equals -4. I'm going to plug that into the second equation because it looks easier. I'm going to solve it for y. You should get -7. So one of my ordered pairs will be -4, -7. I'll write it in a moment. The other one is x equals 2. Substitute that back in. And I get y equals 5. So we have two ordered pairs, and since there's more than one answer, we're going to put it in set notation. Did I go too far? My first ordered pair was -4, -7. My second ordered pair, 2, 5. So this is being very, what's the word? I don't know, like, usually when we write it in set notation, it is in order, but what order do you follow in an ordered pair? Actually follow the order of the x's. So it goes left to right. So when I put it in, I put the -4, then the 2 ordered pair. So actually when I had factored it and solved it, I had purposely put -4 first so I could just keep it in order the whole time because I have those. All right, but I'm not gonna really be that picky about the order that they're written in. It'd be a lot easier if you had them in the correct order. All right, how about the next one? Let's look at it. What would we solve for? X or Y? Which one is not like the other? The Y. We've got an X, we've got an X squared, and we've got a Y. So X and X squared are kind of related, Y is not. Let's solve for Y. Which equation should we solve for Y? Top one. Put it into the second one. Simplify. Set equal to 0. How would we solve it? How are you going to factor that? Quadratic formula. Let's sing the song. You ready? Am I by myself? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Are you gonna take your ACT?
Yeah.
You gonna take it? You a junior? Okay. If you are a junior, you're taking it in March. If you're a senior and you're planning on taking it again, you know you can use your graphing calculator on the ACT. And you know you can put in programs into your graphing calculator or literally type those in your calculator if you want. And everybody in the entire United States that takes the ACT can do it too.
Wait, it's allowed?
You don't have to.
They do not clear your calculator. All they do is check that you have a legal calculator, because there's some calculators you can't use. But anything that you put in your calculator is fine. And again, it is that about speed and about accuracy. So I would hate for you to use a quadratic formula on the ACT and not feel it. Type a new calculator. Like, do something to help yourself. Go download a program that does the quadratic formula for you. Just for the ACT. Not for our test is half non-calculator anyway. So, but do it for the ACT. If you want help doing that kind of stuff, come see me in study hall. All right, going back to this. Sorry, I just want to make sure you have all the advantages that every other kid that takes the ACT has. So we plug it in, we get -1 plus or minus square root -3 over 2. So what's x equal? Uh-huh. That means there's no real solution. Yeah. So we're done. No real solution.
We need to specify.
No, I don't know. That's the way that it was written when I saw it. I mean, no solution is solution. If we're trying to find where the two graphs overlap, there's no solution. Okay. Solve using substitution. So, which variable should we solve for? What?
Because you have the same amount.
Yeah. So Michael said you could do either, because for these, we have x, we have y, we also have x squared, and we also have y squared. So you can really do either. Let's do... Let's solve for x, because we didn't do that in the other two. Let's solve for x for this one. And I'm going to use the second one to solve for x. So we solve for x to get y plus 2. We have to plug that into the first equation wherever we see an x, which is multiple locations. All right, how am I going to simplify this?
Distribute it first.
What am I distributing?
4.
What 4?
The 4 to the 1.
The -4?
Sure.
The -4?
Yeah.
Okay. I'm going to distribute a -4, but I'm not going to do that first. I am going to do that, but I like to work left to right. So what am I going to do first? Mom. Foil it, right? We're going to foil this out. I've done this so many times that I know the answer to that. The more you practice it, you would know it too. Then we're going to combine like terms.
I was just gonna say, cancel the 4.
Which force?
Probably they can do that now.
Yeah. So I'm just going to combine like terms, but just suggestion, as you combine like terms and you use them, maybe cross them off. I grade lots of papers where some students will just accidentally skip a term and like forget about it. So if you cross them out, maybe that'll help you with some silly mistakes. So I get 2y squared, I got a 4y, and a -4y. Those cancel out. And then I have another -4y. Then I have a 4 minus 8, and then when I move that to the other side, I'm adding 4 on. So it cancels out, right? So what should we do? Yeah, we're going to factor it by the greatest common factor. Pick out your DCF. Set each factor equal to 0. And we get 2. Now what should we do? So to solve for x, I'm going to take y equals 0. We're going to plug it into one of the originals. Which one should I plug it into? Second one, right? X minus y equals 2. So for y equals 0, we're going to do x minus 0 equals 2. So x is 2. That's for y equals 0. And then we also have y equals 2. We're going to do x minus 2 equals 2. So my ordered pairs are ooh, good job. 2, 0, 4, 2. Make sure you put them in order X, Y. Don't just put the Y first because we found it first. Make sure you put X, Y. Pretty easy stuff, right? The rest is graphing calculator, so go ahead and flip the page. You're going to find this stuff on your calculator, and because of that, the work that will be graded will be the equation you type into your calculator. So just show me on your homework what equation you're typing in your calculator. I'll show you while we do notes. Example 4, solve using a graphing calculator. I cannot type in x minus y equals 3 in the calculator. What do I have to type in instead? I have to make it y equals, and I'll just call it y1 because that's what it says on the calculator, y1. If I move the y over and I move the 3 back, I get x minus 3. So there's my y1. I will type it in the calculator in just a moment. My y2, I got my other equation, x minus y squared equals 1. In order to type it in the calculator, it has to say y equals. So what do we do? So, well, I'm going to add the y squared, then subtract 1, but you can do it that way too. I have to square root, but if you square root, you got to do plus minus, right? If you do square root, you also do plus minus. So now we have y equals plus minus square root x minus 1. Can you type in plus minus in the calculator? You cannot. You're going to type in 2 separate equations. So you will have a y2, which is square root x minus 1, and you will have a y3, which is negative square root x minus 1. So that will be the work that's going to be graded besides your answer. That will be the work that will be graded when we do this, when we grade it tomorrow. Go ahead and type those in. Call me over if you have any problems with your graphing. Okay, so it says window. Go ahead and hit zoom 6 and that should back. Who else has problems? Whoa, hit zoom 6. Okay, so graph. If I say something like hit zoom 6, you can literally hit zoom and then the number 6. You don't have to hit zoom down, 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 down. Like, it has shortcuts. I'm all about doing the fastest thing possible. Especially when you do ACT. Anybody need help? Okay, so how do we find the intersection?
Second.
Second trace, or second calc, go ahead and do that. Second trace, it is intersect. You can literally type 5, you don't have to hit down, 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 down. Just hit 5. And it asks for first curve. Make sure it is on a line that you, or a curve that you can tell which one it is on. So once you are happy, I'm like, yep, that's my first one, hit enter. And then it says second curve. And you will see if you're looking at mine, it looks like it's still sitting in the same place my first curve was, so it can't be. I have to move it using my arrows. And it takes a while. It's like delayed. Right, it's on the second curve. See how I'm on the second curve? Hit enter. And it says yes. So go close to where the two of them cross. Sometimes the curves cross more than once. So you got to tell your calculator, this is the one I'm looking for. And then hit enter and it will tell you the first intersection. If it's not working for you, call me over so I can help you before we go further. I'm sorry, what? Yeah, I'll do it again. Yeah, to get the other one, you just have to do the same thing again, but that's where people have trouble with this. Okay, it's sitting where x is negative 1 like this, so you move it that way. You guys need help before I go on? I'm doing the other intersection. So second trace, intersection 5. I can't tell what line it's sitting on right now, so I'm going to use my arrow so I can see. Oh, okay, it's on the blue one. I'm good. And then second curve. I just did the red one. So I don't want to do that again. How do I get to the other one? Down. So I'm now on the other one. And then guess, go close to it. And we should get 2 negative 1. If you didn't get it, if it didn't work for you, call me over so I can help you. And we're going to do example 5, same time, just more practice. First thing you have to do is what? You make them say y equals. First thing you got to do is make them say y equals. So when I have y squared equals 4 minus x squared, and we square root both sides, you get plus minus square root 4 minus x squared. You cannot square root the 4 and the x squared. That is not a perfect square. There's a difference of squares, not a perfect square. So then we just have 2 equations to type in. y1 would be square root 4 minus x squared. y2 is going to be negative square root 4 minus x squared. And then our third equation, 2x squared minus 1. parabola, and what's the other thing?
oval.
Well, it's actually a circle. It is, but our calculators are like widescreen, so it looks like an ellipse, but it really is a circle. It is the circle equation. What's the radius?
2.
Yeah, it's the same, 2, 2, 2, the same, it just looks different. Okay, so go ahead and find your intersections. I'm gonna put up the answers so you can check it to make sure you're doing it right. You can ask questions if you are not doing it right with your calculator. Find the intersections.